Hello everyone. Today we will see about the project called as Optimizing Inventory and Demand Forecasting for an Apparel Retail Business. So the project is focused on addressing the challenges that the client, a retail apparel business, faces in forecasting demand, which leads to overstocking, understocking, and revenue loss. Let us see in detail what is a business problem. So before going ahead, let me introduce myself. My name is AiSPRY. I'm working as an associate data scientist at AiSPRY. So let us discuss about the business problem. So the client's main issue lies in their inability to accurately predict future sales for various product categories, resulting in operational efficiencies. This leads to excess stock or stock outs, both of which are costly. The project's primary objective is to improve revenue by ensuring products are available when customers need them, minimize inventory holding costs, and avoid stockouts or excess stock, enhance decision making by providing actionable insights for product launches, promotions, and pricings. The business constraints would be apparel sales are heavily influenced by seasonality, summer, or winter collections. Let us see about the success criteria. When we speak about business success criteria, it will be improve forecast accuracy by 20% across all categories within 12 months. ML success criteria would be achieve MAPE, that would be mean absolute percentage error of less than 10% for forecasting accuracy. Generate reliable forecast for all major product categories. Reduce forecast deviations for high demand products by 20% compared to the current approach. Then we speak about economic success criteria. Reduce inventory cost by 15% within the next 12 months. We understood about the problem, we understood what would be the objectives, constraints, and what would be the multiple success criteria. Now let us see how can we achieve this. Yeah, this is the basic model architecture. How we can achieve this entire how can we achieve our objective? So first, it would be understanding the business and data. We need to understand what is apparel business is and what are the multiple parameters are included in this apparel business. And then we need to understand more on the data. The data provided by the client maybe, we need to understand it, what it says. Mostly the data would contain what are the major cities or what are the quantities required, all these things. So we need to understand that. Then it would be about the data collection. The data from where we are doing the collection of the data. That would be our second step. We need to collect the data maybe from the client server or any other sources or any other databases where the client have stored their data. Then once you got the data, the first step what you need to do is the EDA, exploratory data analysis. You need to apply the first moment business decision, second moment business decision, third moment, and fourth moment business decision. So based on these statistical insights, you will be further deciding what are the multiple pre-processing steps you need to apply. With this, you will be able to understand what is a trend in the data, what is a seasonality, and what is the residue in the data as well. You will also need to do the plots, various plots like line plot, ECF plot, and PSF plot, mainly when we speak about a time series data. The data what we are dealing with is a time series data where time plays a time and date and time. plays a predominant role. Then comes your pre-processing step, where we would be mainly initially handling the missing values. It would be using interpolation or forward or backward fill. We can also use mean, median, mode imputation techniques. Then comes your resampling, that is upsampling and downsampling of the data. Then is the data stationarity. And next step would be the lag differencing. So these are the multiple steps what we have applied when it comes to our data. Then once your data is cleaned, once your data is ready to be used for the model building phase, we will try out with the multiple models such as ARMA model, ARIMA model, SARIMA model, and AR model. ARMA model, it is an autoregressive moving average model. It is a combination of AR and MA models for stationary data. Then comes your ARIMA model, autoregressive integrated moving average. Extends ARMA model by adding a differencing step to handle non-stationary data. Then comes the SARIMA model, an extension of ARIMA that accounts for seasonal patterns in the data. Then comes your AR model. That is nothing but a very basic model, autoregressive model. Focuses solely on the autoregressive component, predicting future values based on previous values. Then comes your MA model, that is moving average model. Focuses on using past forecast errors to make predictions. Once your model is built, once your model is ready to be, once your model is trained on the training data or the data set which you have got from the client. Once your model is trained and which is giving us the good accuracy with the validation data, we will go to save the model. Before that, we need to do the model evaluation as well, where we will be using MAPE as our evaluating metric to evaluate our model, both on train and test data. Once your model is ready, once it is good, giving us a good accuracy, we will save the model. Once a model is being saved, it can be used for a deployment where we have used the Streamlit for the user interface. Then the user can get their new data for the forecasting purpose. They can forecast for the required amount of period. So this is a basic architecture of the project. Basically, architecture gives us a basic flow of the project. So when we speak about the project, we mainly followed this CRISP MLQ methodology, where we have followed business and data understanding. We have done the data preparation, that is pre-processing steps. Whatever the pre-processing steps like handling missing values, handling outliers maybe, or any transformation or scaling methods we need to apply. We have applied it under data preparation. Then comes your model building, where we build the SARIMA, ARIMA, ARMA, AR, MA, all the multiple models. We will try all the multiple models. We will tune that model for getting a good result, for getting a good accuracy or a less error value. So once we have built a good model, of course, we need to do the model evaluation. Evaluation on both training, test, and even on the validation data. Then comes your model deployment. Once your model is built, once your model is ready, we will deploy the model so that user can use it with the user interface applications like Streamlit, Flask, etc. So once model is deployed, the user will be able to use that particular model with their new data. Then comes the monitoring and maintenance part, where the data is taken, where the new data, it will be handled efficiently. So this is something with respect to our CRISP MLQ methodology, which is being followed predominantly in all the projects, which gives us the flow of the project. This is the dashboard after pre-processing of the data. This is the dashboard what we have built. Basically, a Power BI dashboard is a powerful tool that provides stakeholders with real-time insights into demand forecast, inventory levels, and accuracy metrics. By visualizing this data, the business can make informed decisions that minimize stockouts and overstocking, optimize inventory management, and improve customer satisfaction. This dashboard is an integral part of overall system and helps the business move toward more efficient and data-driven operations. What we offer? What we offer from 360DigiTMG, challenging real-time projects that push you to your limits, learning of all phases of project methodology, learning about different tools used in the industry like Python, Power BI, cloud platforms, etc. Work on research paper that published in international journals. Access to various free tools to enhance your learning. The free tools are like Mind Map, ML Architecture Assistant, Resume Optimization Hub, Animated Learning. So these are the few resources which we provide to our students, which are present in our website as well. Thank you, everyone.